Right then, so getting somewhere with the bike build. I don't have a lot of machinery to hand. I've got my lathe, got pillar drill, hand tools, bits and bobs. So I'm making do with what I've got. I have to build a jig to cut keyways basically, which I'm cutting keyways to make splines, because this is a jackshaft and it's going to be running through the center of the main pivot. So we'll have, this is a bottom bracket shell, Bushnell size. I think it's like 56mm ID, something like that. And what will happen then, like this will be machined, so it'll fit inside here. That obviously, you know, it's going to be narrower, kind of like, basically like the Brooklyn Machine Works arrangement, where you've got, I think they called it a torque tube. I'm just calling it a pivot. It'll be sleeved in here, interference fit. I think the Brooklyn ones are press fit with knurling on the torque tube, which kind of like, when you knurl it, it kind of like expands the peaks, and that gives it, like, you know, a proper grip without having to use any sort of clamping. I'll probably end up using like an M6, like two M6 bolts through here, interference fit with this. I think that'll be strong enough. I could probably, even if that, you know, showed that it was turning, I could split this and put a couple of pinch bolts. That would probably just hold it. So this is going to be the arrangement. That's gonna go through here. That'll be attached to the frame. This is going to get bored out to accept these bearings. So what that will mean is that the jackshaft will rotate freely inside what will become the main pivot. The outside diameter of this will be turned down. I ballsed up a bit. I went a bit mad with the bearings. I can't remember what size I got now. There's 689 ZZs, huge bearings. The idea was, obviously, like, the ID would, this would be turned down for the ID of those, and we'd have two each side. But the only thing is, I'm building with T45 steel. I can't find T45 in this diameter, which is a bit of a snafu really, because I really wanted to use these bearings, but never mind. So what were these? These were 58mm outside diameter. I couldn't find any T45 with well, what would be the inside diameter of 58. I mean, you can just see that they're huge. So I'm gonna have to compromise and go for a smaller bearing with the outside diameter of the inside diameter of the largest T45 tube I can find. So I'll put them to one side. They'll come in handy for something. So the jackshaft is probably too long now. This end, the splines aren't very long on them. I understand that. It was kind of like a test that I just progressed with. None of these parts were ever meant to be final parts. I mean, like, you know, they're a bit scruffy. They've been through hell. But they're going, you know, I can use them, perfectly functional. So, like, this Jackshaft, drive shaft, will facilitate using a left-hand drive chainring up onto one of these sprockets. Then obviously that'll drive it forward onto another sprocket, chain going down outside the swing arm onto the freewheel. I'm probably going to make this single speed. We'll give it a go. I've got the means to change it up and put a cassette on. You know, that's more than feasible. So how it'll work, we got the bearings, a little bit tight that end, but that's good. So they'll be interference fit, nice press fit into the, well, I don't know, what can we call it, torque tube. That's what Brooklyn call them. I think I call it Mary, I don't know. Then we've got 2 sprocket carriers. These sprockets, track sprockets, I think I can't remember the diameter of the thread. It's a 24 thread per inch. Managed to cut it because they're obviously thread per inch. I've got a metric lathe, so I have to make allowances for that and get special gears for the gearbox on the lathe to facilitate cutting 24 TPI. So that's the sprocket carrier. Obviously it's going to be left-hand drive, so the right-hand threads, I don't need left-hand threads on here because the drive will self-tighten the sprocket on, possibly to a point where I won't be able to get it back off, but we'll see. So that's, you know, it's a nice fit on there. Probably, apart from all the scratches and stuff, it's probably like the most accurate machining I've done so far, so I'm pretty happy with those. And then, pretty simple, sprocket will go on there. The end of the shaft's going to be tapped probably like M6. Doesn't need much. There's no real pull or pushing forces left and right. It's all going to be rotational force. So basically, you know, just like I'm going to cut a taper, make a tapered sleeve to go over the M6. So that'll drop it in a little bit to keep it a bit more flush. So that'll just hold that on. Same again. These track sprockets, they are kind of stepped, so it's about, I think it's about 10 mil difference each side. So if the chain line's not quite right, they can be rotated, but I quite like the way they look butted up to the outside of the sprocket carrier. So same again, this will get a taper cut into it, and then same again this side, M6. Nice fit on there. You know, I mean, these splines, they were cut by hand on like a Chinese 7-inch by 14-inch mini lathe. They're not the most sturdy thing. Somewhat accurate when they're adjusted properly. There we go, nice fit in there. You know, they do the job. So that'll be the finished assembly. It's really bloody wide at the moment. The bottom bracket I'm using on the frame, which is here. Most of the tubes are cut. Most of the tubes are cut. I got to find more T45 38mm. Possibly find some T45 to make the seat tube, or I've got the option, I've got the lathe, I can leave it at 38, use the biggest seat post I can find and just turn myself a shim. That'll probably be what I do anyway, just to keep. I like the look of the 38mm. I mean, it's pretty fat tubing. I'm not worried about weight. It's going to be a downhill play bike. Yeah, you know, it's not a cross-country bike. It's not an enduro bike. It's going to be a fun park bike with no real intention of pedaling it other than downhill. So weight is not an issue here, which is good because I'm not very good at welding thin tubes anyway. So basically, I can make a start now on. Probably my best bet would be to get the crankset that I'm going to use, and I know that'll give me the space in. The bottom bracket, the reason I'm using just a plain sleeve Bushnell type bottom bracket is so I can use an eccentric bottom bracket shell. Not sure if this will go back together now. Yeah, so yeah, that's how it works. Eccentric, because when there's a chain running from the drive sprocket on the cranks up to the idler, you're going to want to be able to adjust it. I mean, I could technically work out exactly where it's going to be, so the link line, you know, the links are just right, but that doesn't help when you've got wear, or you know, it's not going to be accurate enough. So the idea is that you put an eccentric bottom bracket in, put your chain on, and then when you turn this, it, you know, basically pulls the crank down and tightens the chain, which will be, you know, for the drive side at least. For the for the left side, sorry, not the drive side. Well, that is going to be, it's a bit confusing because the drive side is normally on the right, isn't it? So the drive side will be on the left. We'll call it the idler side, will be on the right. To tension the chain on the idler side, I'll have something very similar to this, except it'll be a bit smaller. I haven't got a drawing, but it's basically like what Starling are using on the stern. Same principle, obviously smaller hole. It'll have an offset hole for the axle. Yeah, it'll be put in basically like a small version of this. So what happens then is that you make your chain as short as possible, and then when you're ready to tension the chain, basically just turn the sleeve in the swing arm, and it'll draw the axle around and to the back. Also opens up possibilities for adjusting bottom bracket height and possibly I can slightly adjust chainstay length as well, which is nice. Or, you know, you've got not bottom bracket drop, but I can lift the bottom bracket up within reason, because I still got to be able to tension the chain. And obviously for the axle side, I could lengthen it, shorten it, even like raise it, lower it. You know, there are slight adjustment possibilities there as well, but the main function will be just for tension, basically. So yeah, eccentric is the way to do it. Eccentric is as eccentric does. So that's where we're at. I'm pretty happy with this. I'm gonna have to shorten it, because I got a feeling, I haven't measured it up yet. Like I said, it was just a test. I know I can cut the splines on the shaft relatively easy now. I've got the method down. So that'll be the next thing, I suppose, is to find more T45. I'm trying to source oval T45 as well with a company called Performance Metals. I'm not sure if they're part of another company that I bought the tubing that I've already used, but I know, well, I think they supply another bike manufacturer. I'm not a manufacturer, I'm just some guy in a shed dicking about. I know it's out there. I'm not sure whether they're keeping it, perhaps. I'm not sure, but I'm not getting much of a response off them. Probably gonna have to ring them. I'm not getting any answers on emails or Instagram Messenger, so I'll be giving them a ring soon to see what they can do. If I can't get it, I'll probably have to switch over to 4130. Again, not sure if I can get oval 4130, but we'll see. Might have to change completely and end up using round, like a smaller round, and make a kind of triangular swing arm, something like BTR do. I don't know yet, it just all depends. I'd like to use a single swing arm like the old Brooklyns. That's the idea. That's the look I'm going for. So there we are. That's it. That's where we're at. Probably do another update soon if I can. Thanks for watching.